Hello and welcome. For this video today we're going to look at electrical circuits, and the two topics are going to be electric current and potential difference, and there are a couple of formulae that you need to know and understand and be able to use for this particular topic. Now firstly we'll look at electric current, and to start us off, if we imagine we've got a wire here, a metal wire, and it's carrying electric current. Now, what we mean by carrying electric current at the very basic level is the flow of electrons. So if I imagine my electrons are these little green dots are electrons, they are flowing through the circuit, and with the flow, as they flow, they carry a charge. Each one has a small negative charge, and they carry that charge through the wire. Now, to be a bit more specific about electric current, we can say that electric current is actually the flow of charge. And if we want to measure that, we can use an instrument called an ammeter, and you can put your ammeter in the circuit like so, and that would measure the amount of current flowing through, and it would measure the flow of charge. Now the problem with measuring the flow of charge is each one of these electrons carries a very tiny charge, and it's difficult to measure the charge on each one of these alone. So what we do is what the machine does, the ammeter does, is it measures the charge on a whole bunch of these electrons, and the actual amount is this many. It's 6.24 times 10 to the 18, so it's actually this number here. This many electrons passing through the ammeter in a certain time is the amount of charge flowing through. In actual fact, we call this number of electrons, the charge on this, a number of electrons, we call that 1 coulomb. So the charge carried by this many electrons is 1 coulomb of charge, and the amount of charge passing in 1 second tells you the current. Now you don't need to remember this number, it's just there just to show you how we actually measure the amount of charge flowing through. So I'm going to get rid of that just in case that's confusing. But basically electric current is a flow of charge, and we measure it on a large number of electrons, and we call that amount of charge 1 coulomb of charge. Now if we were to look a bit more closely at what's going on, at say one little section there, we could magnify it, and you can imagine then perhaps that we have our electric or our wire, and we have these electrons flowing through. Now if we have 1 coulomb passing a particular point, let's just say that point there, in 1 second, we say that is 1 amp. Okay, so that amp, that's the measure of the current, and we say it's 1 amp. So basically current is the flow of coulombs per second, and we could put that, or we could look at a formula that can help us to work that out. Now unfortunately we have some strange letters for our words here, but again, unfortunately you have to remember them and what they mean. You will be given this formula in the exam, but you won't be given the units for each of these measurements. So I actually stands for the current, and it's measured in amps. Q over here stands for charge, and it's measured in coulombs. Capital C, that's an A, and T, that's a slightly easier one, that's actually time, measured in seconds, or just given an S. Okay, so this actually shows that we can measure current by measuring the charge of coulombs per second passing a particular point, and that's what our ammeter here does. So let's just do a quick worked example. We have a charge of 3 coulombs passing a point in the circuit in 2 seconds. What current is flowing? This is just a case of putting the numbers into the formula. So to answer this question, you'd have to use this formula, and we'd have Q over T, and the Q is the charge in coulombs, so that's 3, so it'd be 3, and the time is 2 seconds, so the current equals 3 over 2 equals 1.5, and what's the unit? Amps. Okay, so that's an overview of what we mean by electric current. The next thing I want to look at is this idea of potential difference. And potential difference, another word for that in actual fact is voltage. You can use either one of these in the exam, but this question set will use the word potential difference. So just make sure that you understand that potential difference and voltage is the same thing. Now to illustrate this, we've got a circuit over here. I've got a battery. Just to do a quick recap on our symbols, here's an ammeter, here's a lamp, and here is a voltmeter. And this voltmeter is measuring the potential difference across this lamp. Now what do we mean by potential difference? Now this is quite important. The potential difference is actually the work done per coulomb of charge that passes through the component. So for every coulomb of charge that's passing through here, there's a certain amount of work done, and that work done per coulomb is the potential difference. Now what do I mean by work done? In physics that means energy transferred. So for every coulomb that passes through this lamp, there's a certain amount of energy that's transferred to the lamp to make it light up, and that amount of energy is called the potential difference. Okay, so here you can imagine there's coulombs of charge flowing through. They are passing energy to that lamp to make it light up, and that amount for every coulomb is the potential difference. Now let's have a look at the formula for working that out. So it goes like this: V equals W over Q. V actually stands for potential difference, or you could say voltage, and the unit is volts. W is work done, and remember, very importantly, that just means energy transferred. Squeeze that in, energy transferred, and if it's energy transferred, that's got to be in joules, which is a J, and Q we've come across before, that's our charge, and again that's in coulombs with a capital C. Okay, so again you will be given this formula in the exam. You will be told what the different things mean. You won't be given the unit, so it's important that you remember what the units are. And just to round it off, let's do a quick worked example. We've got the work done on a lamp in this circuit is 20 joules when 5 coulombs of charge pass through. Calculate the potential difference. So these coulombs of charge are transferring 20 joules, and there's 5 of these coulombs, so we would simply use this formula: potential difference or voltage equals energy transferred, which is 20 over 5 coulombs, and that is simply 4, and the unit is volts, okay, or 4V. So here we go, the potential difference across this lamp is 4 volts. It's probably important to remember that when you do connect a voltmeter to measure the potential difference, it has to be across the component, because it's measuring the difference in energy per coulomb across the component. Okay, so a couple of tricky points there, but very basic points. You must understand those, and do go over it again if you're not quite sure. And remember, all the videos for physics, chemistry and biology unit 2s are on the website www.my-gcsescience.com. Thank you for watching, and see you again soon.